Dear friends, welcome you all for today's discussion. Today we will discuss about regenerative cycle. In previous discussion, we have discussed that how we can increase mean temperature of radiation by using reheat cycle. In which the reheat cycle is the cycle in which we totally take back whole of the exhaust steam before exhausting to condenser. Take back total steam at lower pressure and temperature and bypass it from the boiler where exhaust gases, hot gases we will use to reheat the steam, and the reheating up to the same temperature or below maximum temperature at the constant pressure. Then we expand in the low pressure turbine. So in this process, we can see that the quality of the steam parameter remains satisfied, means quality of steam should not fall below 85%. So reheat is a very effective method to increase mean temperature of radiation and increase performance of the thermal power plant. So here today we are going to see that how that is another process, that is a regenerative process by which we can further increase mean temperature of heat addition. Here time and again we talk about the mean temperature of heat addition because we have seen that thermal performance means Rankine cycle efficiency, that is basic of the thermal power plant running on the steam as a working fluid. So efficiency of thermal power plant, or you can say Rankine efficiency of the plant is a function of mean temperature. So mean temperature, by increasing mean temperature we can increase the efficiency of the thermal power plant. That is the purpose of increasing mean temperature. So here by regenerative method, regeneration, we can increase mean temperature of addition. So what is regeneration? Instead of taking whole of the steam at low pressure and low temperature and reheating in boiler, we use a small quantity of steam at low temperature and pressure and mix it with the feed water, because you know that in steam there is a huge quantity of the, energy. When it will condense, it will release huge quantity of energy, and low temperature water coming from the condenser when mixed with the steam, it will be heated up to higher temperature. So when higher temperature water is supplied back to the boiler, so lesser quantity of the heat required to convert water into steam, and most of the heat energy will be utilized for increasing the temperature of the steam. That is a purpose of the regenerative method of increasing mean temperature of the heat addition. So instead of bypassing whole of the steam at low temperature and pressure to the boiler and reheating it, we take small quantity of the steam and mix it with the feed water and increase the temperature of feed water, and it will increase up to 80-90 degrees centigrade. So lesser quantity will require to convert hot water into steam. So most of the heat generated in boiler will be utilized to converting saturated steam in further into superheated steam. That is a purpose of the regenerative cycle. So let us draw a schematic diagram showing all processes of the reheating or all processes of the regenerative and showing on the TF diagram. Then we will explain, and we will also in this discussion show that how mean temperature of heat addition will increase in this process. So let us first draw a diagram. So see, this is a regenerative cycle in which we can see this is a turbine and this one is generator, and here is a boiler. So from boiler, steam enters into turbine at saturation temperature. We have considered that steam is heated up to saturated temperature. Just it is in actual case it is heated up to the superheated steam, but to explain how we can increase mean temperature of heat addition in this way, that is why we have taken up to saturation point, just to compare that without regeneration and with regeneration how mean temperature of heat addition is increased. That's why we have taken that steam enters from boiler to the turbine at saturation temperature, and from here we take at point 2. This is this state we take M1 quantity of steam by passing M1 quantity of steam at this state 2 means temperature 2 and pressure, and we take another quantity M2 quantity, because here from this point to this point to 1 minus M1 remain, and once we take M2 quantity of steam, so here you will find after taking M2 quantity of steam, we will have only 1 minus M1 minus M2 quantity of steam go to the condenser after expansion here. So from this point to this point, expansion process, only 1 minus M1 kg of steam. Here we say that 1 kg of steam is in flowing. So only we are calculating for per kg of steam. So here it is 1 kg. Once we take M1 kg, so remaining steam 1 minus M1 will expand from state 2 to state 3, and here we taking M2 quantity, so remaining quantity will be 1 minus M1 minus M2, that will go into condenser. Here it will come in contact with the cold water coming from the river, stream or canal. So once this steam will come in contact with the condenser, it will condensate. So condensate is again pumped back here from the pump 1 to the feedwater 2. Here M2 quantity will mix with 1 minus M1 minus M2, because here 1 minus M1 minus M2 quantity of the water will be there, and it will mix with M2. So here you will see only 1 minus M1. Here 1 minus M1 quantity will remain, and once 1 minus M1 quantity will enter here, M1 quantity of steam will mix with 1 minus M1 quantity of water, so it will come here 1 kg. So again in this circuit from here, this pump number 3 will pump back to the boiler 1 kg of the water at higher temperature. This is a way how it works. Now same thing we will show on the TF diagram. So let us minimize size and draw TF diagram. We draw same thing on TF diagram, temperature enthalpy diagram. This is a temperature enthalpy diagram. Starting from state 1, because already we have taken that this is a saturated state. So state 1 is a saturated state. We have taken saturation state 1 and expanding here up to 2, and here at point 2 at pressure, the pressure P1, and this is the pressure P2. Here M1 quantity of steam is taken back from state 2. M1 quantity of, so remaining quantity will expand from point 2 to point 3, state 2 to state 3, state 2 to state 3. Here steam that is 1 minus M1 quantity will expand from state 2 to state 3, and then here M2 quantity again taken back for heater number 2, M2 quantity of steam taken back to heater number 2, so remaining quantity will now go to condenser 1 minus M1 minus M2, 1 minus M1 minus M2 of the steam will go to the condenser. So condenser stage, this one is a 4, condenser stage is a 4, and 4 to 5 is a condensation process. 4 to 5 is a condensation process. So again reaching up to saturated liquid state 4 to 5, and from 5 to 6 it is a again pumping process. So 5 to 6 is a pumping process, 5 to 6 is pumping process, and 6 to 7 is a regeneration process. This is a 6 to 7, because from 6 to 7 mixing will take place. M2 quantity of steam is mixing with the 1 minus M1 minus M2 quantity of the water. So M2 kg of the steam is mixing with 1 minus M1 minus M2 quantity of the water. So this is state 7. This is state 7, you can see, and this again pumped back. Again this one pumped back from 7 to 8. 7 to 8 again pumped back. So this one is 7 to 8. 7 to 8. Again when we reach 7 to 8, again M1 quantity is mixing here. And 7 to 8, it will reach to 8 to 9. 8 to 9. Now 8 to 9 we reach here from 8 to 9, because M1 quantity is mixing with M1 quantity of steam mixing with the 1 minus M1 quantity of the water. So it will become 1 kg. So 9 to 10 is a 1 kg of water pumped back to the boiler. This is the process complete. So 10 to 1, you can see 10 to 1 is a heat addition process in the boiler. Instead of, because of now heat addition process is only now remaining from 10 to 1. So you can see that earlier if without regeneration, heat addition process would have been start from 6 to, this is a 6 point, from 6 to 1. But due to regeneration, now same heat is added from 10 to 1. So heat addition taking place at higher temperature. So certainly mean temperature will increase. And from formula we can also define what is the mean temperature of regeneration. So T mean, if you define T mean regeneration, T mean regeneration equal to H1 minus H10 upon S1 minus S10, S1 minus S10. And T mean without regeneration, regeneration equal to H1 minus H6, H1 minus S6 upon S1 minus S6. And we know that quantity of the heat H1 minus H10, H1 minus H10 is a quantity, these are same. Here you know that H1 minus H10 equal to H1 minus H6. Quantity of heat added in the boiler are same. But you can see that S1 minus S6 is much larger. You can see S1, this is S1 minus S6. This one is a S1 minus S6. And this one is a H10. S1 minus S10. So S1 minus S10 is much less compared to S1 minus S, because denominator are same, these are same, but this value is greater than this one. So T mean with regeneration increases, you can see from the graph. T mean with regeneration is higher than T mean without regeneration. So by using, we have used in this process chart, we have used two bypassing of a small quantity of steam we have taken at state 2 and state 3, mixing with feedwater coming from the condenser at first feedwater 2 and feedwater 1. So in this way we have increased the temperature of heat addition up to 10. Now final in boiler you can see heat addition takes place from 10 to 1. Earlier it was without regeneration 6 to 1. So mean temperature is increasing. So here you can see from the definition of the mean temperature of regeneration H1 minus H10 upon S1 minus S10 entropy difference. So this value is higher than this value because numerator are same. Denominator of this one is less than this one. That's why by this process, by regeneration method, we can increase mean temperature of heat addition. Once mean temperature of heat addition increases, we know that Rankine cycle is a function of T mean temperature that we have earlier proved that this is already again we have proved here that mean temperature of addition is increasing thermal efficiency. The thermal efficiency of Rankine cycle is a function of mean temperature. So by regeneration also we can more effectively we can increase thermal efficiency compared to reheating. In reheating process, we are not taking this steam to reheat in boiler, but taking a small quantity of the steam from the turbine itself and mixing with the feed water. So increasing mean temperature of addition from this point to this point, T6 to 10. So this is a increase of the mean temperature. If it increase of the heat addition process, temperature is increased, so mean temperature is also increases. So I think this is crystal clear to understand how mean temperature by regeneration method we can increase. So now we can calculate other things. You know that we have to find out what is the thermal efficiency. So rest of things are same. You have to see what are how much heat is added and how much you can either find out from here this diagram or this diagram. You can calculate So here important thing is that we have to find out how much quantity is taken from this one and this one. We have to find out M1 and M2. So let us find out M1 and M2. Let us remove this one and we use energy and mass balance at heater 1. Energy and mass balance equation at heater 1. Because most of the exams in GATE examination and Indian Engineering Service examination, this type of diagram was given and enthalpies are given. You have to find out either missing enthalpy or you have to find out M1 and M2. This is by given data. If you know how we write energy balance equation, you can find. So you can see energy balance equation for heater 1. So energy balance equation you have to apply for heater 1. So see here, we take another color. This one, at this point we have to apply energy balance equation at this point. So you take H2 into M1, H2 into M1 and plus यहाँ पर in this heater you can see two streams are coming, M1 into H2 and plus H8 into 1 minus M1, H8 into 1 minus M1 plus 1 minus M1 into H8 equal to H9, 1 kg 1 into H9. So balancing this one, H2 M1 into H2 plus H8 minus M1 into H8 equal to H9. So M1 H2 minus H8 equal to H9 minus H8. M1 equal to H9 minus H8 upon H2 minus H8. So this is how we find M1. You can find from this relation thing M1. Same thing apply. Once you get M1, now you can find out M2. So applying energy balance equation for heater 2, apply energy balance equation, energy and mass balance for heater 2. Heater 2, this is a feed water heater, not heater, but feed water heater 2. So let us now erase this one, energy balance. So see here you can see M2 into H, because this is state 3, M2 into H3, M2 into H3 plus, so this stream is also going. So here you can see incoming streams are M2 into H3 plus 1 minus M1 minus M2 into H6, 1 minus M1 minus M2 into H6 equal to coming out stream from heater 2, 1 minus M1, because M2 will mix here, so remaining quantity will be 1 minus M1 into H7. So you can find out M2 in terms of M1, and M1 we have already calculated from heater 1. By this energy balance equation, there is no need of calculate, because already we have calculated M1, and here you have to balance equation and you can find out M2 in terms of M1. Rest of things are known for you. You can easily calculate M2. So this is a way of writing energy and mass balance equation. And now we have to calculate other quantities for thermal efficiency, W net, everything. So let us calculate other things. Find out W net. How much? W net means W turbine minus W pump. So how you can get turbine work? Because turbine work taking from here to here, from here to here, from here to here at 3 stages at different quantities, because we have taken quantities M1 M2 by passing from the turbine. So turbine work will be structured. So WT equal to in first stage 1 into H1 minus H2, and from stage 2 to 3 quantity will be 1 minus M1, because M1 is taken back for the reheater regeneration. Okay, remaining quantity will be 1 minus M1 into Now enthalpy will be H2 minus H3, H2 minus H3 and plus here again we have taken back M2 quantity of steam, so remaining quantity will be that will expand from 3 to 4 will be 1 minus M1 minus M2. So 1 minus M1 minus M2 into enthalpy difference is H3 minus H4, H3 minus H4. So this is a turbine work. Now we have to find out pump work because pump work has to be subtracted from the turbine work. That's why we will get W net. So WP equal to, there are three pumps, WP1 plus WP2 plus WP3. So again we have to write equation for WP, pump 1, pump 2, pump 3. So for pump 1 you can see quantity of steam which is flowing 1 minus M1 minus M2 and enthalpy difference are there. So 1 minus M1 minus M2 into enthalpy difference H5, H6 minus H5, H6 minus H5 and plus for pump 2 quantity will be 1 minus M because M2 is mixing here, so remaining quantity will be 1 minus M1. That is 1 minus M1 into enthalpy difference H8 minus S7, H8 minus S7. Same thing you can see from the TF diagram also, but here we are saying either you can see from TF diagram or you can see from the process diagram. If both are properly drawn, you can use any diagram for writing these equations. Now for pump 3 you can see only quantity that because in pump when 1 minus M1 is mixing with M1, so remaining quantity will be 1 kg only. So 1 into H10 minus H9, H10 minus H9, that is a pump work. So this is you can, by putting all values in numerical terms, you can find out pump work and turbine work. Most of the cases in such type when numerical question come, pump work is neglected because compared to turbine work, pump work is insignificant. Most of the cases in solving a vehicle problem, it is given negligible. So turbine network is almost equal to W10, WTR. If it is not given, then you have to calculate it by given data. So W net now you can find out. Now next thing is that what is a heat supplied Q1. Q1 equal to heat supplied means input energy given. Here you can see input energy given only from H10 minus H1. This is the only way. H10 to H1 is heat energy is given, so it is equal to H1 minus H10. This is a enthalpy difference from exit of the boiler to inlet of the boiler. So this is the amount of heat given in this way. So this is a Q1, and now you can find out thermal efficiency and thermal equal to W net upon Q1. So now you put all these values. It is the same thing that we have calculated for any cycle, whether it is a single stage cycle or reheat cycle or regenerative cycle. These formula equations remain same, only terms will increase, number of steps will increase, but equations remain same. So this is the thermal efficiency. If you want to calculate steam rate, so again I want to define steam rate formula of steam rate. So now steam rate, that is a kilogram of steam, kg of steam required per hour to generate 1 kilowatt of net power. It is a 3600 upon WT minus WP kg per kilowatt hour. This is a steam rate. So all these things you can find by using equation, and I think regenerative method is more efficient compared to reheat cycle because this one is a more easier way to increase the main temperature. Instead of taking whole of the steam back to the boiler and using exhaust gases for reheating purpose. This is a qualitative, more easier and not having very complex way to increase the main temperature because small quantity of the steam you can take back and use reheater and feed water coming from the condenser. You can use 2 or 3 reheaters and increase the mean temperature variation. If it's a preheating of the water, preheating of the condensate water up to the high temperature. You can heat it up to 120 degrees centigrade, because at high pressure, boiling point of water will increase. So you can increase the temperature up to 120 degrees centigrade in regeneration process. So I think this is important, and in next lecture we will use both cycle, combination of reheat and regeneration. This is the most efficient way of increasing mean temperature of irradiation, and most nowadays in modern thermal power plant we use reheat and regenerative cycle in combinations. So these type of questions you will find in the big exam like Indian Engineering Services Examination and Indian Civil Service Examination. If you opt mechanical engineering as one of the optional subjects, so you will find such kind of questions. In GATE examination, questions only of you will be given this block diagram and data in terms of enthalpy at different points will be given. Either you have to find out missing enthalpy, some missing enthalpy will be given. If all enthalpy will be given, then you have to find out missing mass rate. So any kind of question will be asked. Only thing you have to learn is that how to apply energy and mass balance equation, which is first law of thermodynamics. You know law of continuity, mass will remain constant, and you know from the law of conservation that energy is conserved. So these two laws can be combined together, and it becomes energy and mass balance equation. So you can once you practice 2 3 questions first type, you have to be careful for the taking units, because units are very important. 50% mistakes people students generally occur due to lack of practice and lack of knowledge about units. So thank you very much for watching this video. Please like and subscribe it. It will motivate me to make more and more videos for you. Thank you very much.